Okay, in problem number 6, you have a baseball that was thrown at an angle of 53 degrees from the horizontal. We are given the initial speed, which is equal to 40 meters per second. And in letter A, you are asked, what is the maximum height reached by this baseball? So to solve for the maximum height, we have to get the y component of 40 meters per second, and that would be done using this equation. V sub y is equal to 40 meters per second sine 53 degrees. And this will give us 31.94 meters per second. This would be the initial speed of the baseball along the vertical. Okay, we know that at the maximum point, the v sub f is equal to 0 at the maximum point. We can now use this equation, v sub f squared minus v sub I squared is equal to 2gy, wherein we are looking for y. So by formula transformation, we will get y is equal to v sub f squared minus v sub I squared all over 2g. Our v sub f is equal to 0. Our v sub I is 31.94 meters per second. And g is negative 9.8 meters per second squared. Solving for y, we will get 52.06 meters. And following the rules and significant digits, you will get 50 meters. This is our maximum height. Now in letter B, you're asked, what is the time? How much time is needed to reach this point? Okay, so we compute now for the time to reach the maximum height. Okay, to solve for this, we can use this equation. V sub f is equal to v sub I plus gt. And we have already solved for the initial speed. Along the y-axis, it's 31.94 meters per second. And our v sub f, right at the top, is equal to 0. So 0 is equal to v sub I, which is 31.94 meters per second, plus the g, negative 9.8 meters per second squared, multiplied by the time. Solving for t, you will get 3.259 seconds, or 3 seconds after rounding off. Okay. In letter C, we are asked what is the time wherein, at which two time is the height equivalent to 25 meters. Now in this trajectory, there will be two times when the ball will reach 25 meters. This point, as the ball goes up and as the baseball goes down, you will have 25 meters from the ground. Okay, so that will happen twice. So the equation that we can use here is this. Y is equal to v sub I t plus 1/2 gt squared. Again, we are dealing with the y-axis, so we have to use 31.94 meters per second for our initial speed. Okay? And it says in the problem, in letter C, 25 meters. So positive. We are going to solve the portion when the baseball is still moving upward. So 25 meters is equal to v sub I, which is 31.94, and then just copy t, plus 1/2. The g is, negative 9.8 t squared. Okay. We rearrange the equation, you will get 4.9 t minus 31.94t minus 25 is equal to 0. So we have now a quadratic equation. How do we use this? We have to use the quadratic formula. Or in your calculators, you know the shortcut on how to solve for the time. Since this is a quadratic equation, you will get two answers. Okay? Our A here is 4.9. Our B is negative 31.94. And our C is negative 25. Okay? As a reminder, our quadratic equation says that A is equal to negative B plus and minus square root of B squared minus 4AC all over 2A. You can do away with this if you're going to use your scientific calculator. Okay, that would be a shortcut. By using your scientific calculator, you should be able to get the following answer. The following answers. T sub 1 is 5.608 seconds. And T sub 2 is equal to 0.909 seconds. Rounding off, you will get 6.0 seconds. And this one, you will have 0.9 seconds. Okay? This 0.9 seconds refer to this portion, while the other one, 6 seconds, will refer to this portion, the time of flight it takes to reach this point.